welcome to the discussion of section 2.4 where we're going to learn how to work with inequalities. I like to go over this just as a video because we're going to get into section 2.7 where we learn about absolute value inequalities. So you need to know how inequalities work before you get into that for sure. So notice I have lots of Pac-Man up here. So if you don't know what Pac-Man is, I'm getting to be an old teacher. Been teaching 25 years, and I'm starting to find some of my students don't even know what Pac-Man is, which really makes me feel incredibly old. All right, well, anyway, I'm going to look at some inequality symbols here, and these are the different possibilities that you see. First of all, we have the less than symbol, which reminds me of Pac-Man's mouth. Okay, so less than kind of goes like this. The idea would be if you had something like 4 is less than 5. That's a true statement. Whatever is to the left of the symbol is smaller than what's to the right of it. So a lot of times teachers will say, Pac-Man gobbles up the biggest number. There's a 10, there's a 7. So Pac-Man gobbles up that big number like that. Burp. Okay, so that's how that goes, all right? So we also have greater than, and the greater than symbol, of course, looks like this. Right, and it would go like this. Again, you can think of something like, as an example, 7 is greater than 2. Okay, in this case, let's say that you had 100 here and say you had 50 there. Again, Pac-Man gobbles up the bigger number like that. Geez, I wish I had the theme song. I don't know how to play the theme song on the guitar. I should have learned it just for this video. Shoot. All right, so that's how that goes. All right. And then the next one we have is less than or equal to. Now, less than or equal to goes like this. You could have something like 5 is less than or equal to 7. That's a true statement because 5 is a smaller number than 7. That is true. But you could also have something like 5 is less than or equal to 5. In that case, that's true. So one of the things you want to kind of get confident with is if you have the statement 5 is less than or equal to 5, that's true because it's okay for this to be less than this or for them to be equal. However, if you had 5 is less than 5, then that's a false statement. Okay, like that. So that's the difference between the two. The equal to a bar allows for them to be equal. Okay, and then here's another one like this. So you could have, I guess we could put a little line on Pac-Man like this. So let's say that's 6. That's 5. Okay, 5 is less than or equal to 6. Or you could have them as equal if you wanted to. So you could also have 6 is less than or equal to 6 like that. Okay. Then we have the greater than or equal to symbol, which works in a similar way. So for instance, you could have 7 is greater than or equal to 0. That's a true statement. Okay. Or you could have something like 0 is greater than or equal to 0. That's also a true statement because they're equal to each other. Okay. So what's kind of important to get what inequality symbols are, whether they're true or false, and what these 4 different statements are. The one that we see also is not equal to. And not equal to, I was kind of thinking about this thing that I found on the internet about Pac-Man and Miss Pac-Man. A lot of times back when I did some computer programming, we used to use this to show not equal. So look at that. We got Miss Pac-Man here and we got Pac-Man there. So that kind of made me think of that. All right, so those are the different symbols. You want to be sure that you know the difference between less than, greater than, less than or equal to, greater than or equal to, or not equal to. That's the point. All right, so next thing we want to do is kind of look at different notational systems. If we have set builder notation, you write an inequality like this. All right, so, and you read this bar right here, this little set symbol, braces represent set. So that's saying the set of. Whenever you see that brace, that's saying set of. Such that is that bar. So it's saying the set of numbers, x, such that is the bar. Then you have the condition x is greater than -2. So again, that you say set of numbers, such that, and then x is greater than -2. That's the condition, okay? So we're going to look a little bit at number line graphs. So I'm going to zoom on this a little bit so it displays a little bit better on my video as I do these. Okay, so what this one is showing is it's got all of the numbers that are to the right of 1. All right, So first of all, if you're to the right of something, then you're going to be greater than. All right. However, this is a parenthesis, and a parenthesis is going to mean that endpoint number 1 is excluded from the solution. Okay, so the way you write this in the set builder notation is you write this like this. You say set of, and just pick a variable, x is pretty typical, such that bar, then you say x is greater than 1, and then you close the symbols like that. Okay, so if you're going to the right, basically if you're going like this is going to translate into a greater than symbol like that. Okay, there's basically 4 possibilities on these. Okay, the next one is the same thing, except it has a bracket. So it's bracketed at 1 and then going ever to the right. So if you have a bracket, that means that you are including that 1 in the solution, like that. And then you write this like this. You would say set of numbers x such that, then you would say x is greater than or equal to 1. So what you're going to notice on this is if you have a parenthesis, it's to the right, it's greater than. If you have a bracket to the right, that's greater than or equal to. So in this case, 1 is a solution. And in problem number 1 is not a solution. That's the difference between the symbolism of a parenthesis and a bracket. Okay, moving on to the next ones. Now we're going to the left. So if we're going to the left, then we're talking about less than. All these numbers are less than 3. That solution is showing on a number line all of the numbers less than 3. Okay, it's got a parenthesis. Parentheses mean you exclude from the solution. So 3 is not a solution, it's only a boundary. Then we would say the set of all numbers x such that x is less than 3. So you're going to notice on this that if you have a parenthesis shaded to the left, that means less than. That's how that translates. Okay, and then the next problem, you again are going to the left, so it's going to be less than, but since you have a bracket, that means that you are going to include that -4. So you say set of x such that x is less than or equal to -4, and then you always close the bracket like that. So this is the 4 possibilities that there are. It's just the language of the graphical solution. Okay, and the reason we shade that is because, you know, if you look at the problem I just did, there's an infinite number of numbers that are less than or equal to -4. Plus you have all these decimals, fractions, everything like that. So there's actually, this is kind of a heavy thought, but there's an infinite number of what we call integers like -5, -6, -7. But if you looked at between -4 and -5, there's also an infinite number of numbers between those. So it's kind of weird. There's infinity within infinity in a sense. Okay, so here's another one. This is a little bit different one. If you look at this, the way that this is supposed to come out on my paper, I'm going to redraw this so you can maybe see this a little bit better. There's supposed to be a bracket on -6, a bracket on -2, and then you're shaded in the middle. There's an infinite number of numbers between -6 and -2 because you have decimals and fractions and stuff like that. So we're in between 2 numbers. So what this problem is saying is it's saying the graph says that the solution is between the numbers -6 and -2. Like that. -6 is included because there's a bracket. -2 is also included because there's a bracket. Okay, so -6 and -2 are solutions in that graph. And then in set builder notation, it's a little bit different now. You say set of, you still say x, you still say such that. Now you put the -6 and you put the -2. You put an x in the middle of them like that because it's in the middle of those 2 numbers. Then you use 2 less than or equal to symbols. So that's the way that you would write that in set builder notation, is like that. And the reason we're doing less than symbols is because if we use greater than, we wouldn't be saying something's true. -6 is a smaller number than -2. That's true. However, if we wrote -6 greater than or equal to -2, that's false. because it's not bigger. -2 is a bigger number, so remember Pac-Man is eating the bigger number. Okay? All right, so that's how that goes. Next problem on here, I want to just kind of highlight how this one's going. You're supposed to have a bracket there, parenthesis on 3, and shaded in the middle like that. Okay, so what this problem is saying is you're between the numbers -1 and 3. That's got a bracket. -1 has a bracket on it, so that means that you are including that as a solution. The 3 has a parenthesis on it, which means you're excluding that. So the mathematical meaning of this is all the numbers, decimals, fractions, everything between -1 and 3, including -1, but not including 3. And then you write this like this. You say set of x such that, start with the left boundary. You always do this from left to right. Then the right boundary, put x in the middle. You're including the -1, so use less than or equal to. You're excluding 3, so put less than. And then that's the way you would write the solution on that then. Okay, so that's kind of a good summary to show you how graphs work out then, so that's important. Okay, we're going to now look at what we call interval notation as another way of naming an inequality in a graph like this. So there are 4 cases. I'm just going to go through each of these 4 cases. First of all, you would have like x is less than a. That just means the graph is going on forever to the left. So graphically speaking, you would have a parenthesis. You're excluding the a, and then you would shade forever to the left like that. So that's how that graph's going to go. All right. And then the interval notation, see, we name this. If you're going forever to the left, this way is -infinity. This way is positive infinity. So if you're going to the right, it's going to positive infinity. If you're going to the left, it's going to -infinity. So we say forever to the left, comma, a, stop at a like that. All right, so that's how that goes. All right, and a is just the endpoint. Okay, the next example would be less than or equal to. So it's the same idea with one difference. Since there's an equal to bar, that means you're shading to the left. The graph is going to the left because it's less than or equal to, but the only difference is you're going to have a bracket there. So the interval notation is the same. You're going to the left, so you start with -infinity. Stop at a, then bracket it. So this thing right here, that equal to bar, is what's making that a bracket. Okay. Then the next one is greater than a. This is forever to the right this time. And this would look like this. You would have a parenthesis shading to the right. And if you go to the right, infinity's on the right. Okay. So you would start with a, with a parenthesis, and then go all the way to the right like that. Okay. Forever to the right. And then the last one is x is greater than or equal to a. So the slight difference on this is it's going to be a bracket. Then it's going to be shaded forever to the right like that. Okay. So what you want to notice on this is if you have greater than, what are you doing on greater than? You're going to the right. So in interval notation, infinity is to the right. Okay. If you do a less than, like the first 2 examples, then you're going to the left. So notice the infinity, or more specifically, -infinity, is on the left. So you want to get that straight in your mind. Less than goes to the left, -infinity on the left. Greater than goes to the right, infinity on the right. And then there's the difference between the brackets and parentheses. Now, one thing that you might want to do on this, parentheses represent open intervals. It means the endpoint's not included. A bracket represents closed interval, means the endpoint's included. And you never do this. It's wrong to do something like this. You never, ever, ever put a bracket on infinity, because infinity is not closed. It's open. It goes on forever. So you'll notice on this that, and this was not a mistake, is every time I have infinity, that needs to have a parenthesis around it. Okay. All right. Now what we're going to do is do some work with graphing, doing interval notation. Okay, so we want to get really comfortable with doing that next here. Okay, so if you're going to graph this, I'm going to go ahead and just graph this. -4 is where we are. This is a greater than or equal to symbol. which means we're going to go to the right. Since there's an equal to bar, that means we're going to put a bracket right on that -4, and you're going to shade, and then be sure you put an arrow. There's a couple of things that are important. You have to put that arrow. If you don't, you're wrong. You have to put the bracket that way, and don't do something silly like write it that way. I see students doing that. That looks like a rocket or something. That's not a correct way to write a graph. So it goes like that. So that's how you do that specifically. And then there's a couple of things on this. -4 is included because of the equal to bar. And then interval notation goes like this. You always have a comma. Start, comma, finish. Okay? Starts at -4. Since it goes forever to the right, infinity goes on the right. So it goes like that. You bracket the -4, but you use a parenthesis on infinity. So that's how that goes. Okay, moving to the next page. All right, now this one, what we're going to do is a similar thing. So we're looking at -3. This time we've got a less than symbol. Less than means go to the left. We do not have a equal to bar, so we're going to use a parenthesis, and then we're going to shade and put that arrow like that. So that's how that goes. This time we are excluding -3 from the solution because there's no equal to bar. And then it goes like this. Interval notation. If it goes forever to the left, then infinity's on the left. And you got to be sure you have negative infinity. Then it ends at -3, then parenthesis like that. Okay, so that's how that goes. Now the next thing I'm going to do is pause this, let you do a few problems. The next 4, you want to make sure that you're very solid on all of these cases. So I'll pause and let you work those out. Let's see how we did here. So let's see, to begin with this, let's go ahead and just get the graphs. So I want to go through and do all the graphs the first time here. So this is a greater than or equal to. Okay, so we're going to go -5. Greater than means to go to the right. We have an equal to bar, so you should have bracketed it. And then you just shade like this, put an arrow. Okay, like that. The next one is less than or equal to. Less than means going to the left, so you're going to start at 0. You do have a closed interval, since you have the equal to, so put a bracket like that, and then shade showing that you're going forever to the left. Okay, like that. Okay. Now I'm going to go ahead and finish the graphs, then go back and do the interval notation. Okay, the next one is a less than. Less than we know goes to the left. This time it's an open interval, so use a parenthesis. So go to 4, use a parenthesis, right on the 4, shade the number line, put that arrow like that. Okay, then the next one you have 5 halves. Well, 5 halves, if you take 5 divided by 2, 5 divided by 2 is 2, 2 times 2 is 4, you have 1 left over, so that's 2.5. Okay, so what we need to do is just go to 2.5, halfway in the middle. This one is greater than, so we're going to go to the right. It's an open interval, so use a parenthesis and then go like this. 5 halves is 2.5 or 2.5. So that's how all of your graphs should have went. All right, now what I'm going to do on this is let's look at the greater than. You have this greater than and you have this one. Whenever you have a greater than, and think about the interval notation. Remember, you always got commas separating. Okay, but if you have greater than, you're going to have the infinity on the right, like that. Okay, that's what that's saying. Now, what we'll do is we start this one at -5, and then we have a bracket, just like the graph. This one we start at 5 halves, and then it's open, so we do that. So this one we would call a closed interval. This one we would call an open interval. Okay, the -5 is closed. Okay, this one, now we're looking at less than. Less than means that you're going to the left, so the infinity goes on the left. But we use negative infinity with parentheses. The end point on this one is 0 with the bracket. Okay, scrub that off there. Okay, and then this one goes to 4, and it has a parenthesis. So that's what you should have. See, this one was closed, and then this one's open like that. Okay, very simple. Okay, next thing we're going to look at, I'm going to transition for a minute into what I would call in-between inequalities, I guess. And we can also have a graph that represents that x is in the middle of two numbers. And this is how this is written. So if you look at this, this is really saying x is in the middle of -3 and 1. And since we have, the equal to bars on both of those, that's going to mean -3 is included and 1 is included. So they are an included part of the solution. So what you do in this case is you see x in the middle of two numbers, typically with two less than symbols, like that. You're going to go to -3 and include it. You're going to go to 1 and include it. So that means you're going to put a bracket on -3, a bracket right on 1, then you're going to shade in the middle like that. Okay? Interval notation is very simple on this. You just start at -3, comma, end at 1. So there is no infinity because this is a closed interval between two numbers. Okay? All right, and then the next one's the same thing. You see x in the middle of two numbers. 0 is smaller than 4. So what's happening on this one now is, since you have a less than or equal there, that's going to mean that you are including. Since you have a less than, that's going to mean that you're excluding the 4 from a solution like that. Okay, then when we go through and we do the number line graph, you're going to go to 0, you will include it, so you'll put a bracket. You'll go to 4, exclude it, so put a parenthesis, and shade in the middle. Okay, interval notation's just like the number line graph. Starts at 0, includes it, comma, 4, exclude it. Like that. Left to right is always how you name these things. Okay? So you got to recognize the language that x is in the middle of two numbers. Okay? You'll never see this like this. Sometimes I see students write this like this. That's nonsense. Total nonsense. Okay? You'll see, this is saying x is bigger than 4. X is not bigger than 4. X is smaller than 4. But at the same time, x is bigger than 0. Got to think about this. This is saying x is bigger than 0. That's what that says. And then this is saying x is less than 4. That's technically what it's saying. That's why we write it the way we do. Okay, so now what we're going to do is we're going to solve some inequalities and look at this for a few minutes. And you really use a process that's very similar to solving an equation. You can add or subtract both sides of the inequality. You can multiply or divide both sides by the same quantity. So you can do all those things you're used to doing with a basic linear equation. And typically you want to get the variable isolated on the left or right side. I usually tell students when you're learning this, and if this is new to you, it's a good idea to just always put it on the left side. But it doesn't really matter. That's the way I'm going to teach that's like this. You also want to know that these two things are the same. If you see this is saying x is less than 2. This one, if you have 2 like that, this is saying the number 2 is greater than x. So it's the same. The number is smaller than 2. That means 2 is bigger than the number. Think about that. They're exactly the same. And go back to the Pac-Man analogy. Pac-Man's eating the bigger number. 2's the bigger number. Okay, they're the same thing. Okay, excuse me. So now what we're going to do is solve these inequalities. So let's start with this, and we'll try to understand how we can check and understand what the meaning of this problem is. So this is saying you have an unknown number a minus 10 is less than -16. This is a less than problem. Okay, so what we do to begin with is we want to isolate the a. The a needs to be by itself. So if we're going to make the a by itself, the -10 needs to go away. So we need to add 10 to both sides of this equation, just the same way we'd be solving an equation. Well, we know -10 plus 10 is 0, so technically you have a plus 0, and then -16 plus 10 is -6. So you have a is less than -6, okay? And, don't get your calculator out on this. I'm going to keep saying that because this just means you have more debt than you have money. You have $10, then you have $16 of debt. Well, your debt exceeds your money, so you're in the hole, guys, by negative 16 or negative 6. Okay, so now we're going to draw a graph. So I'm going to go ahead and just put a number line graph on. You can do the same thing if you want to. So I'm going to use my nifty little number line drawer here. Ooh, look how cool that is. Okay, all right, so we got a number line. So what we're going to do is just, I like you at a minimum to just go 0, 1, 2, 3, 4, 5, negative 6. You don't have to put all those other numbers on there. You can just put some dashes on there like this. So what this is less than. Less than means we're going to the left of that. So what I'm going to do on this is, like we just got through doing, we're going to put a parenthesis on negative 6, and we're going to shade to the left of it. So that's the picture of it like this. So all the solutions of this inequality are numbers less than negative 6. Okay, if we do this in a interval notation, you have a parenthesis. Anytime it's less than, the infinity is on the left, so we say negative infinity. Then we stop at negative 6, and that negative 6 is excluded from the solution. Okay, now let me show you a couple of ways that you could check and verify this answer. So if you took any number here, let me show you what happened. Let's take like the number negative 7. Negative 7's out here. Okay, it's like right in there. If you plugged in for a negative 7, you would have negative 7 minus 10. Now you want to see if that's true. That is true because this is negative 17, and negative 17 is less than negative 16. It's a smaller number. That works. In fact, every number on this interval right here, there's an infinite number of numbers. If you plugged them in, they would all work. Okay? But if you picked something over here, it wouldn't work. Like, for instance, say you plug in 0. Put 0 in for a. So if you had 0 minus 10 less than negative 16, you'd have negative 10 less than negative 16. That's a lie. That's false. Okay, negative 16 is a smaller number than negative 10 because it doesn't work. So everything to the left of negative 6 works. Everything to the right of it does not work. And even negative 6, if you checked negative 6, if you plugged in like negative 6 there, what would you get? You would get negative 6 minus 10 less than negative 16. That also is false. So it's not a solution. That's why it's excluded. So when you're solving these problems, there's a tendency to do it very mechanically and not really even understand what you're doing. This is what you're doing. You found an answer to all of the solutions of this inequality. There's an infinite number of solutions. That's why we draw a graph and why we do interval notation anyway, say. Okay? All right, now let's move on and let's do another one like this. And I'm going to do this in a pretty similar way. So I'm just going to start by writing 12x minus 14 is greater than. Now we got a distributive property. So 2 times 5 is 10x. 2 times 5 is 10. Like that. Now you can rearrange from both sides if you want to. I'm just going to get my x on the left. So I'm going to keep this where it is. I'm going to move the 10x. So I'm going to subtract 10x from both sides. I'm going to bring down the greater than symbol. I'm going to leave the negative 10 where it is. And I'm going to move the 14. So I need to add 14 to both sides like that. So you can rearrange that way if you want to, as long as you understand that you're adding and subtracting from both sides. So these like terms go together to give 2x. This is 4. Okay, then we're ready to undo the multiplication of 2 by dividing. Okay, that's going to give 1x, like we learned. 4 divided by 2 is 2. And of course, we don't have to put the 1 there. Just bypass that, but understand what's going on. So that would be solution to the problem. So what I'm going to do is I'm going to do a graph like I did on the last problem. So let's draw a number line. So here's my number line. And really all you need to do is just locate 0, go out to 2. That's good enough. You can also add a couple other numbers on there too if you want to, like that. So when we do this, greater than, this is a greater than symbol, which means we are graphing to the right of 2. So we're going to put a parenthesis on 2, right of it. And again, this one is excluding the 2. Okay, there's not an equal to bar like that. Okay, whenever we do interval notation, we have a comma. It goes forever to the right. That means infinity's on the right. Starts at 2 and excludes 2. So that's how your interval notation would go, is like that. Okay. Now again, let me just show you. Let's pick a number that's a solution and just kind of keep it simple. Let's say, okay, x equals 4. Plug it in. Everywhere you see an x, plug it in. It should work. So let's go ahead and do that. So just kind of as a check, we have 12 times 4 minus 14. Maybe, let's see if it's greater than 2 times 5 times 4 minus 5. Okay, this is 48 minus 14. 48 minus 14 is 34. This side would be 2 times 20 minus 5. This would be 2 times 15, which is 30. So we end up with 34 greater than 30, which is true. Okay, that's how you can tell you're right. Okay, now the other thing that you probably want to do, if you plugged like 0 in, 0 would not work. If you plugged 2 in, it would end up giving you the boundary. So if you plugged in 2 for x, you would have 12 times 2 minus 14 greater than 2 times 5 times 2 minus 5. If you work this out, I'm going to do some of this in my head. This is 24 minus 14, which is 10. This is 10 minus 5 is 5. 2 times 5 is 10. It's still a false statement, but since they're the same, that means that's a correct boundary. So I can tell you right. These problems are checkable. It's always good to check the number that you got there, pick a number here and see if it works, and then you're good. Okay, and then everything there is not going to work. Okay. All right, so let's go ahead and do the next 3 problems. I'll give you a little bit of time to work on the next 3. I'm going to pause my playback for a minute. All right, goofing around. Okay, so let's see what we came up with. Okay, let's go around. Let's see if we got these okay. All right, so to begin with, the first one's very simple. All you should have had to have done on this one is got rid of the 25, so you're trying to isolate x. So really all you need to do on this one is divide both sides by 25. That'll give 1x is greater than 0, or just x is greater than 0. Okay, so your graph that you drew should have looked like this. Draw a number line, locate 0, that's all we care about. This is a greater than symbol, you have to know that, so that means we're going to shade to the right of that. All right, so what I'm going to do is go ahead and I'm going to put a parenthesis on this, and we're going to shade forever to the right like that. So we're excluding the 0. That's it. Okay, and then the next we got to do interval notation. Interval notation, since it's greater than, that means infinity's on the right, and it starts at 0 and excludes 0. So you should have done your interval notation like that. Okay, next problem. This one you're going to have to work out, a little bit more work algebraically on this. So we have 24n plus 20. You can't do anything with that because those are unlike terms. Distributive property, 4 times 5 is 20n. 4 times 13 is 52. Okay, then you can rearrange. I'm going to keep the 24n where it is, just write it down. And then this n needs to move over here. So you're going to subtract 20n from both sides. To do that, bring the less than or equal to down, bring the 52 down, and then you can move the 20 over there. So you're subtracting 20 from both sides. So you can write that like that. Now, keep in mind, you can also write your steps this way. To me, I think the higher you get in math, the more important it is to just kind of rearrange things in your head the way I'm trying to train you to do that. But you're really doing this. You're subtracting 20n from both sides. And this is the way students do this a lot. So that's 4n plus 20 less than or equal to 52. Then you subtract 20 from both sides. So you end up getting 4n is less than or equal to 32. And that's exactly what we're going to get over here. So I don't care which way you write your step. If you rearrange, it's just important to know what you're doing on the problem. Okay, then we need to divide both sides by 4. That gives 1n, or just write that as n. 32 divided by 4 is 8. So here we go. So now we're going to draw our graph. Excuse me. And when we draw the graph, I just want to mainly see like 0, 8, like that. This time it's a less than problem. Less than means go to the left. So when we graph this, it's going to look like this. We're going to go to the bracket on 8, shaded to the left. Okay, now we are going to include the 8 because of the equal to bar. That's what made the difference on that. Okay, so that's how that goes. One thing I'm going to do on this one more time. Students tend to be a little bit lazy about checking their answers. It's kind of good to do that a little bit in your homework because it helps you with your arithmetic. So let's take 8. N equals 8 and plug it in. Let's plug it in wherever the variable is in the original problem. Let me show you what happens. So if we do that, we'd have 24 times 8 plus 20 less than or equal to 20 times 8 plus 52. They should be the same because that's the boundary. So if I do 24 times 8, let me challenge myself. Let me show you how I would do this in my head. I can think of this as 25 minus 1 times 8. 25 times 8 is 200. 8 quarters is 200. And then minus 1 times 8 is 8, so that's 192. Pretty cool. Impressed? Okay, 20 times 8 is 160 plus 52. 192 plus 20 would be, what, 212. And this would also be 212. So see, they're equal to each other. So that means that is correct. Now what I can do, I'm going to erase this, and I'm going to show you this. Okay, I'm going to pick a number that's in this boundary. Okay, like for instance, 7. Plug in 7. It should work. Okay, so let's go ahead and crunch everything out. This time I'm going to be lazy and use a calculator. So 24 times 7 is 168 plus 20. 168 plus 20 is 188. Go over here. 20 times 7 is 140. 140 plus 52 is 192. Looks like I kind of threw an extra 8 in there for some reason. Okay, but the point is, this is true. We expected it to be true. Any number here is going to work. Any number out here is not going to work. That's the idea. Okay. All right, next problem. Now this one, hopefully you thought about getting rid of the fraction because that's one of the things we talked about. If you look at 15 and 3, the common denominator, least common denominator is going to be 15 because 15 divides into itself 1 time and 3 also divides into 15 5 times. So what I'm going to do is I'm going to just start by writing down the problem as it is. And I'm going to multiply both sides of this equation by that common denominator. So I'm going to put a bracket around both sides and multiply by 15 over 1. So you want to show that step like this. Okay? Now when you do this, see, you're multiplying, you're not doing a distributive property. You're not taking 15 through that. You're going left to right. So you're just going to really do this right here, and you're going to do this. Okay, and when you do this, see, 15 divided by 15 just cancels out. So that gives basically 7 times x plus 6. Okay, like that. Then when you go over here, 15 divided by 3 is 5. So you've got 5 times x plus 3. So write it down. Bring down the greater than, and you have 5 times x plus 3. Now you distribute. So you're going left to right. Students a lot of times just don't understand this for some reason. If you have 3 numbers, you do not take 2 times 3 times 4. You go 2 times 3 is 6, then 6 times 4 is 24. That's what I'm doing here. I'm going left to right. I do that to get 7, then I go. I multiply this to get 5, then I multiply. Okay, left to right. So now we're ready to do this. So that's 7x plus 42 greater than 5x plus 15. Okay, like that. Rearrange. Get the variables on the left. Leave the 7x. Move the 5. So just move it. So that's minus 5x. Leave the 15. Move the 42. So that's going to be subtracting 42 from both sides like that. So now what you have is 2x there greater than, let's say this is a negative number right here. So if you just do 42 minus 15, you got to regroup. You're really taking away 10 from 40 to make that 30. Okay. And then what you're doing is adding that 10 to 2 to make that 12. So 12 minus 5 is 7. 3 minus 1 is 2. So that's 2x is greater than negative 27. Okay. Then we're going to divide both sides by 2. And that'll give 1x, or x is greater than negative 27 over 2. Okay. So what I'm going to do is we're going to go ahead and do the number line graph to begin with. So you want to just draw yourself a number line. Okay, now the question is, what do we do with this? Where do you locate that? And I see students do that in lots of interesting ways. If you do 27 divided by 2, 2 divided by 2 is 1, 1 times 2 is 2, that's 0, bring down the 7, 7 divided by 2 is 3, 3 times 2 is 6, so you have a remainder of 1. This is really 13 and 1 left over out of 2. So this is really x greater than negative 13 and a half. Or if you took a calculator and did negative 27 divided by 2, you're going to get negative 13.5. Okay, so what I'd want to see on here is 0. Now you don't have to put all these dashes out here. You could just say, okay, here's negative 13, here's negative 14. At a minimum, just do this. Now you are greater than, so greater than means shade to the right. So what I'm going to do on this is just go halfway in the middle of between negative 13 and 14 with a parenthesis, and then go like that. So interval notation, you're just going to say start at, and you can say negative 27 over 2, comma, it goes on forever to the right. And then that's how you'd want to write your answer. Okay, so that's what you should have come up with. All right, so let's take a look at the next topic. And the next topic we're going to be looking at, if you multiply or divide by a negative number in inequality, you have to take extra caution because this does impact things a little bit. So the key thing is, I'm going to just highlight this and read this. When solving an inequality, anytime you multiply or divide both sides by a negative number, be sure to switch the inequality sign. You need to understand why this is. So let's, as an example, just to show you why this is the case, if you started with this inequality, 3 less than 6, you know that's true. Without a doubt, 3 is less than 6. And let's just say let's divide both sides by positive 3. And I'm doing this to show you what happens when you divide by a positive number. So what would you get? 3 divided by 3 is 1. 6 divided by 3 is 2. So this is still true. Okay, the answer is it still true? Yes. Okay, so that's what happens. Now let's go to this second example. We're going to look at 3 less than 6. This time let's divide by negative 3 and see what happens. Okay, so this is real important to understand this. So 3 divided by negative 3 is negative 1. 6 divided by negative 3 is negative 2. See, the thing is, it's no longer true. Okay, so the thing is, the way that you make this true is, see, that's not true. You have to write it as negative 1 greater than negative 2. Now it's true. Okay, because see, the way that negative numbers order themselves is backwards of the way that the positive numbers order themselves. Okay, so on a number line, here's 0, here's negative 1, here's negative 2. Negative 1's bigger than negative 2 because it's to the right of negative 2 on the number line. So what you have to do is, since you divided by a negative number, that's why you got to change the sign. So you have to change the sign on that to make it true. Okay, and multiplication works the same way basically. So I'm going to erase a couple of things and I'm just going to show this to you real quick. Okay, so the idea would be like if you had this same example and you had 3 is less than 6, and let's say that we decided to multiply both sides by a negative number. If you multiply both sides by a negative number, this is negative 6, this is negative 12. Which number is bigger, negative 6 or negative 12? Okay, negative 6 is bigger. Okay, so you have to change that sign. So if you multiply by a negative, you have to change it. So that's the thing. Anytime you multiply or divide by a negative, switch the inequality sign. If you multiply or divide by a positive, nothing changes. So that's the idea. Okay, so let's work some problems out. So this problem right here, you have negative 3x greater than or equal to 15. So you need to isolate x, which means if you're going to isolate x, that means that you need to divide by the number in front. So we're going to divide both sides by a negative number. So we are going to have to switch because that's a negative number, right? That goes to x, that's 1x. Okay, like this, 15 divided by negative 3 is negative 5, but you have to switch that to less than or equal to. Okay, if you didn't do that, your answer would not check. So if you wanted to check, you just pick a number less than negative 5. Like for instance, negative 6. If you plug in negative 6, you would have negative 3 times negative 6, and if you multiply that out, notice that you get something that's true. Okay, so you got to switch the sign on that particular problem. Okay, next problem. Start by writing the left side down. These are unlike terms. You can't put them together. You want to do a distributive property, so that's negative 12r plus 44. Be really careful about that. You can think of that as a negative times a negative. Even though that's a subtraction symbol, it represents adding a negative number. Subtracting 11 is the same as adding negative 11. Okay, now we're going to rearrange. Now what I'm going to do is just bring the less than or equal to down. I'm going to leave this where it is. I'm going to move this. So that now becomes plus 12r. I'm going to leave the numbers on the right side. So I'm going to move the 16. So it becomes minus 16. Collect the like terms. This is negative 4r. If you take 44 and subtract 16, you're going to get 28. Then you're going to be ready to divide. You have to divide both sides by negative 4 to isolate the variable. Okay, so that's going to give 1r or r. We did divide by a negative, so we must switch the sign, and that's negative 7. So that's the solution of the problem. Okay, now I do want to show one other little aspect on this problem. I want to show you what happens, like if you did the problem a slightly different way. Now I'm going to start this the same way. I'm going to just bring down the left side, do a distributive property to get negative 12r plus 44. Now this time I'm going to get all my variables on the right side. So I'm going to leave this where it is. I'm going to move this to get plus 16r. I'm going to leave 16, and I'm going to move the 44 to get negative 44 like that. Okay, if I do this, this is negative 28. This is 4r. Now I got to divide by 4, and since I divide by 4, a positive number, I do not switch this. So I want you to notice that these two answers are the same. The preferred way is to write it this way. That's preferred, but they're the same. Okay, Pac-Man is eating up the R. Okay, same thing. Okay. All right, so let's work some problems. Let's go ahead and work out 22 and 23. Okay, let's take a look and see how we did. Got to do a distributive property on this one, so that would be negative 25y. Negative 5 times positive 16 is negative 80, so I just put subtract 80. Okay, I'm going to get the y on the left side because that's the preferred way to do an inequality. So leave this where it is and move this. So that moves over here to give plus 30y. The sign changes. Do this. So you're adding to both sides so the sign doesn't change. Okay, and on this one, we're going to leave this where it is. And we're going to add 80 to both sides to move that over there. So that's plus 80. Like that, okay? So what we have here is 5y less than, and let's see if we do 80 minus 35, you can regroup like that to give 45. That's positive 45. Now see, I didn't change the sign because what I really did, when I move stuff, I'm adding and subtracting. Okay, now what I need to do is divide by 5, and see, since I'm dividing by a positive number, this thing will not change. That stays the same. So that's going to end up giving 1y less than 9. So any number less than 9 would check. Like if you plugged in 8, or if you plugged in 7 or 6, or anything less than 9, it should work. All right, so that's how you should have done that one. Okay, the next one is we're going to start with the distributive property. So we're going to have negative 4 times x is negative 4x. Negative 4 times 9 is negative 36. And then bring down the minus 21x. Same thing here. Negative 3 times 5 is negative 15x. Negative 3 times 4 is negative 12. And then minus 3x. Now you have a bunch of like terms. So you need to put those two things together. And you need to put these two things together. Get your like terms together before you start rearranging. So this is negative 25x when you put those two things together. Still have the minus 36 less than, and then negative 15 subtract 3 is negative 18x, and then subtract 12. So you want to start there. Now let's get all the x's on the left and all the numbers on the right. Now you can show your step this way too, or you can do it in your head. If you add 18x to both sides, if you want to do this kind of like this is going to be negative 7x, like that. Okay, so what I have is negative 7x here, minus 36. That goes to 0. This is 0 minus 12, so that's negative 12. Okay, now what you're trying to do is isolate x. So what you want to do is add 36 to both sides. Okay, when we do that, that goes to 0. So negative 7x is what's left on this side. And then 36 minus 12 is 24. So we're down to this point. Okay, so now we have one more step that we need to do to complete the problem. If we're going to isolate x, we have to get rid of multiplying by negative 7. So we divide by negative 7. And since we're dividing by a negative number, you should have switched that sign. So you should have got x greater than negative 24/7. See, that's a negative answer. You have a positive divided by a negative is a negative, so you just write it like that. You could also write it as x greater than negative 24/7. Just have the preferred way is the negative in front of the fraction bar, but either way is okay. Okay, so hopefully we did those okay. Just kind of know when and when not to switch the sign. Okay, now we're going to look at, to finish up, just a few more things I want to look at is what happens when we have an in-between inequality and we're solving this. So what you try to do on this is you want to get the t in the middle. The variable needs to be in the middle of these two inequality signs all by itself. So that t needs to be isolated. So that means what you're going to need to do is get rid of the 1 and the 4, and you have to do this to all three parts. We call this a three-part inequality. So let's start by just writing down this. Okay, so what I'm going to do is I'm going to start by getting rid of the minus 1. I'm going to add 1 to all parts. So you can write the step this way if you want to. So you would get 7 plus 1 is 8. That would go to 0, so that is 4t less than or equal to 24, like that. Okay, now what you want to do is you want to get rid of the 4 so that t is by itself, so you divide by 4. Okay, crunch out the arithmetic. 8 divided by 4 is 2. We divided by a positive, so that does not change. That's 1t or just t. And nothing changes on the inequality. 24 divided by 4 is 6. So we end up with this. Okay, so if we were to draw a graph on this, graphically, this is going to look like this. We just draw a number line graph. What I would want to see is 0, 2, 3, 4, 5, 6. And then what we're going to do is we're going to include the endpoints. So you want to do this like this. You want to put a bracket on 2, bracket right on 6, and then shade in the middle, like that. Interval notations, just like the graph, it starts at 2, ends at 6, and again, you are including those 2 endpoints like that, okay? Now, one thing that you can kind of see on this, too, to help you understand the problem is just check the endpoint. So if you went back to the original problem, I'm going to write down the original problem. We have 7 is less than or equal to 4 times t minus 1 less than or equal to 23. Now, I'm going to show you what happens on this, and this is kind of important to see. So if you checked a 2, if you plug in a 2, that endpoint, what are you going to get? You're going to get 7 is less than or equal to 8 minus 1 is less than or equal to 23. Whoops, so I think I got everything right there. Okay, so what do we have? 7 is less than or equal to 7 is less than or equal to 23. Okay, that's right. 7 is equal to 7, so that's okay. All right, so that's fine. Okay, now I'm going to erase this and let's do the other endpoint. Let me show you what happens on the other endpoint. Okay, let's plug in 6. So now let's see what we get. We have 7 less than or equal to 24 minus 1 less than or equal to 23. So we've got 7 less than or equal to 23 less than or equal to 23. That's okay. 23 and 23 are the same. That just means that's the endpoint. Okay, so that works. Let's go back and do a couple other things. Okay, let's pick a number somewhere in the middle. Let's say, how about 4? Let's plug 4 in and see what happens. Okay, if we do that, we have 7 is less than or equal to 16 minus 1, less than or equal to 23. 7 is less than or equal to 15, less than or equal to 23. That's true, it's in the middle. 15 is in the middle of 7 and 23. So that's right. And let's do one more thing. So let's do something that doesn't work. Okay, how about 0? 0 doesn't work. Let's see, it's not in the shaded solution. Plug it in. So what you would get is you would get 7 less than or equal to 0 minus 1 less than or equal to 23. So that would be 7 less than or equal to negative 1 less than or equal to 23. That's false. Okay, negative 1 is not in the middle of those 2 numbers. So that's kind of how that works. If you play with that a little bit, it'll help you understand what you're doing in this problem, say. Okay, checking helps students understand stuff a lot. Okay, let's go to the next problem. I'm going to start by writing it down. We have negative 11 less than or equal to negative 2c plus 3 less than negative 5. Okay, so what we got to do is we have to isolate the c in the middle. So we have to get rid of 2 things. You got to get rid of the 3 and you got to get rid of the negative 2. And you have to do the operations to all 3 parts of this inequality. So if we're going to get rid of a add 3, we subtract 3. And we must do that to all parts like that. We have to do it like that, in that order. Okay, so that's going to make that go to 0. So write down what you have. This is negative 14 less than or equal to negative 2c plus 0 is just negative 2c. Less than, and then that's 2 debts, so that's negative 8. Okay, now we got to get the c by itself. So that means the way to do that is to undo the operation of multiplying by negative 2. So you're going to divide everything, all 3 parts, by negative 2. All right, we just got through dividing an inequality by a negative, which means we do have to switch these signs. So that's real important that you do that. All right, so let's do this. That would be positive 7, That's going to be C. That's going to be positive 4. That's it. Okay, let's draw a graph. All right, so I'll draw a number line. That's so cool. Man, I love using the tools on this. All right, so here's what we're going to do. Got a 0, get a 4, 5, 6, 7. Now be sure that you do this, but it's shaded between 4 and 7. So what I'm going to do is we are including the 7 because of the equal to bar. So we're going to have a bracket there. We are excluding the 4. So we have a parenthesis there, and then we're going to shade in the middle like that. So that's how your graph goes. Okay. Now, interval notation, do not do this. I see students do this all the time. They want to say 7, 4. It's totally wrong. Okay. Put it in order. You want to go 4, 7 bracket like that. Okay. And again, what would happen if you checked the endpoints? If you just took 4 and plugged it in, that would give you negative 11. If you plugged 7 in and worked that out, that'd give you the right endpoint. If you plugged in, say, like 5, you would end up getting a number in the middle of negative 11 and negative 5. Okay, like there, and so forth. So it checks a lot like the last problem did. Okay, so let's do these next 2 problems, and then we'll finish up with one word problem. Okay, so let's see how we did. All right, so I'm going to start by writing this down. Yeah, well, all we need to do on this one is divide each part by 3. Be sure you do that. So it's going to be 3. It's going to be x. That's going to be 8. Okay, now these signs do not change. The reason is because I divided by positive 3. You divide by a positive number, nothing changes. So this is just saying it's all the numbers in the middle of 3 and 8, not including the 3 and including the 8. It's all in the numbers in the middle of 3 and 8, not include 3, but include 8. Right? Your graph should have went like this. So you should have drawn a number line. Just want to have 0, 1, 2, 3, 4, 5, 6, 7, 8. Just label the key numbers. And it should have went like this. Do not include the 3, so parenthesis. Include the 8, so bracket. Then go like that. And don't do it like this. Okay, a lot of times I see students do it like that. That's totally wrong. Make those things enclose like that. Interval notation is just like the graph is. 3, 8. Exclude, include. Like that. Make sure you draw it, make your brackets and parentheses readable. Okay, and then on the next problem, I'm going to start by rewriting that. Negative 16 less than negative 2z. Subtract 4 less than or equal to negative 8. Start this one by adding 4 to each part. You can write your step this way if you'd like. You can draw a line if you would like, or you can just work this out. That is negative 12 less than or equal to negative 2z. That goes to 0, so you just have negative 2z in the middle. That comes down, and then that's negative 4. Now, nothing changed. If you add to each part, nothing's changing. Now, you're isolating z, so that means you're going to have to undo the multiplication of a negative number, so you're going to divide by a negative number. Since you're dividing by a negative number, you should have changed both of those symbols. That's very, very important that you see that as you're doing these problems. Okay, so this is 6. That becomes z, and this becomes 2. And see, the thing is, 6 is bigger than 2. So Pac-Man is devouring the bigger number, see? Okay, that's another way to help you understand that, I guess. All right, so draw your graph. So it will go like this. Draw a number line. Get the key numbers, which are 2, 3, 4, 5, 6, like this. And then probably a 0, like that. And you're including both, so you'd have bracket on 2. And you would have a bracket on 6, and then shade in the middle. Interval notation would be bracket 2, 6, problem done. Okay. Okay, so the last problem, and of course you can check your answer on any of these like I showed you. Let's take a look at this one. This says Paul has 2 grades of 65 on his first 2 tests. What does he have to score on his 3rd test to have an average at least 80? Okay, first of all, how do you average numbers? If you average 2 numbers, what do? You add the numbers and divide by 2. If you average 3 things, which is what we're going to do, is you're going to add the 3 numbers and divide by 3. So you'd actually have to average like this. You would have the first test plus the 2nd test plus the 3rd test. Then you'd have to divide that whole thing by 3. Okay, well, instead of putting a question mark, of course, what do? We put an X there. Okay, so that is how you would average the 2 tests we knew, and then the 3rd test that we haven't taken yet. Okay, okay, now you've got at least. At least means 80 or bigger. So that is going to translate to a greater than or equal to. It can be 80, so it can be equal to 80, or it can be bigger. So that would be the inequality that would solve this problem. So what you'd want to do, first of all, you'd want to combine these 2 like terms. So you would want to do 65 plus 86. So we want to do that. So that adds up to 151. So we have 151 plus x, all divided by 3, greater than or equal to 80. So what I'd like you to see here is we have a fraction. Get rid of the fraction. So if you multiply this side by 3 and that side by 3, then that'll divide out the 3's. So you're just left with 151 plus x greater than or equal to 240. So now you just need to solve this inequality and then you're done. So all you really need to do on this one is subtract 151 from both sides. So this is going to give x here greater than or equal to, and then let's just do 240 minus 151. So I'm going to regroup. That's 3, that becomes 10, that's 9. You got to regroup again, so make that 1 and then make this a 13. 13 minus 5 is 8, so 89 should be what we get. So he needs to get an 89 or bigger. If he gets an 89, he has an average of 80. Okay, so that's kind of what he needs to do. So if he wants to have a B in the class, I guess, he's got to have an 89 or bigger. So I do want to show you one thing, just kind of real quick with my calculator. I like to show off the technology on the calculator every now and then on this. So I'm going to pull up my calculator and show you something. Okay, if I was to now average these 3 numbers up, look what would happen. So if I was to take 65, let me get this thing adjusted just a tad bit so you can see everything here. Okay, so if I was to take 65 plus 86 plus the 89, I would get this. Now divide by 3, I would get an average of 80. Okay, so that's the idea. That's the calculation I just did. That's how you verify you're right. Okay, so that will take us through this whole section, and this will help you get ready for the next 2.7 where we learn about absolute value inequalities. Thanks for watching. Hope this helps, and have a great day.